What if death wasn't the end? What if growing old, getting sick, and eventually fading away weren't natural laws of biology, but simply bugs in the system? And what if we could fix those bugs, just like editing a document on your computer? Imagine deleting the gene that makes your hair turn gray, or rewriting the gene that causes your heart to weaken, or even swapping out the gene that programs your cells to age in the first place. Welcome to the world of gene editing. This isn't a fantasy ripped out of a sci-fi movie. Right now, scientists are actively using gene editing tools like CRISPR to cure genetic diseases, fight cancer, and explore ways to literally slow, or reverse, aging. But here's the wild question: could gene editing one day make humans immortal? That's the conversation we're having today. Before we dive into immortality, let's break it down. Gene editing is the process of altering DNA, the instruction manual of life. Think of DNA as the blueprint that tells every cell in your body what to do. If there's a typo in that blueprint, say, mutation that leads to disease, gene editing lets scientists cut, copy, and paste to fix it. The most famous tool for this is CRISPR-Cas9, which works like molecular scissors. It can find a specific gene, cut it, and either remove it, repair it, or replace it. Sounds simple when you say it fast, but this is one of the most powerful breakthroughs in biology since the discovery of DNA itself. Right now, gene editing is already changing lives. Patients with sickle cell disease, an inherited blood disorder, have been cured by having their genes edited. Scientists are experimenting with editing genes to treat blindness, muscular dystrophy, and even certain types of cancer. We're at the dawn of an era where diseases that used to be life sentences could be deleted from existence with the click of a molecular button, but curing disease is just the beginning. If you can fix what's broken, what's stopping you from upgrading what's still working? Here's where it gets fascinating. Aging isn't just wear and tear. It's also written into our DNA. Our cells carry genetic programs that tell them when to divide, when to repair themselves, and when to stop. Over time, those programs accumulate damage, mistakes, and signals that push us toward decline. Some genes literally accelerate aging. Others act like brakes, slowing it down. In fact, scientists have already discovered longevity genes in certain animals that live unusually long. Bowhead whales can live over 200 years. Naked mole rats are resistant to cancer. What if we could borrow their genes, or switch off the ones that make us vulnerable? In recent years, researchers have made stunning progress in reprogramming cells. Using gene editing, they've been able to reset cells back to a more youthful state. In mice, they've reversed signs of aging, improving muscle strength, eyesight, and even extending lifespan. One of the key discoveries is the role of telomeres, those protective caps at the ends of our chromosomes. Every time a cell divides, telomeres get shorter, and when they get too short, the cell dies or malfunctions. By editing the genes that regulate telomeres, scientists have been able to extend the life of cells far beyond their normal limits. Now imagine applying that to humans. Instead of your cells giving up at 80 or 90, they could keep regenerating, keeping you biologically young even as your calendar age climbs past 100, 120, maybe even beyond. This idea has a name: longevity escape velocity. It's the point at which science adds years to your life faster than time takes them away. With each breakthrough, we might extend human life by 5 years, then 10, then 20, until, theoretically, death becomes optional. Gene editing could be the key to pushing us across that threshold. Picture a world where you walk into a clinic at 60, get your genes edited, and walk out with the biological profile of a 30-year-old. Then you repeat the process every couple of decades, essentially hitting the reset button on aging. It's not eternal life in a mystical sense. It's maintenance, upgrading your body like updating your phone. Now, let's slow down. Can gene editing actually make us immortal? Here's the truth, immortality isn't just about genes. Our bodies are complex systems, and aging is influenced by countless factors: environment, lifestyle, random cellular damage. Even if we edit the perfect genome, accidents, infections, or new diseases could still claim us. But here's the thing. Immortality doesn't have to mean indestructibility. It could mean functional immortality, the ability to keep the body young, healthy, and reparable indefinitely, unless something external intervenes. Think of it like a car that never breaks down from old age but can still crash. Of course, with great power comes controversy. If gene editing can extend life, who gets access? Will it be a luxury for the rich, or a right for everyone? What happens to society if millions of people stop dying at 70 or 80 and instead live to 150? Do we expand retirement age to 120? Do we risk overpopulation? And then there are moral questions. Is it natural to rewrite the code of life? Should humans have the right to edit themselves into immortality? Some argue it's playing God. Others argue that curing aging is no different from curing cancer, it's just another disease. And let's not forget the risks. Gene editing is powerful, but it's not perfect. Mistakes, called off-target effects, can cause new mutations or unintended consequences. Imagine editing a gene to prevent aging, but accidentally triggering cancer instead. Until the technology is flawless, immortality could come at a terrifying price. There's also the danger of misuse. Could someone create designer humans with enhanced strength, intelligence, or immunity? Would we end up in a world divided between the gene-edited elite and the natural-born majority? The gap between rich and poor could become a gap between mortal and immortal. But let's dream for a moment. It's 2045. You walk into a longevity clinic. A doctor greets you, not with pills, but with a genetic upgrade plan. They take a sample of your blood, feed it into an AI system that maps your entire genome, and identify the exact genes responsible for your aging profile. Then, using advanced CRISPR or next-generation gene editing, they reprogram your cells to repair DNA damage, regrow youthful tissues, and keep your organs biologically fresh. A few weeks later, you notice your energy returning. Your skin looks younger. Your memory sharpens. Medical scans show your risk of age-related disease dropping by 90%. You're 70 years old on paper, but biologically, you're back to 35. And every few decades, you'll come back for another upgrade. That's not immortality in the mystical sense, it's practical immortality. Aging becomes a choice, not a curse. If that happens, the world changes completely. Retirement, pensions, even the concept of generations could dissolve. Imagine grandparents and grandchildren both looking 40. Imagine leaders in politics and business holding power for a century. Imagine relationships where, till death do us part might stretch for 200 years. Would people still take risks if they had centuries to lose? Would innovation accelerate, or slow down as people cling to long lives of comfort? These are the questions immortality forces us to face. But let's bring it back to you. Imagine being given the choice, one simple procedure that could reset your biological clock and give you another lifetime. Would you take it? Or would you worry about the consequences, the unknowns, the risks? Some people dream of immortality. Others see beauty in mortality, the idea that life is precious precisely because it ends. So, can gene editing make humans immortal? Maybe not in the invincible superhero sense. But it might just give us the closest thing to it, the ability to live far longer, healthier, and stronger than any generation before us. Immortality may not mean never dying, it may mean never aging, never declining, never being forced to say goodbye before you're ready. The real question is, if the code of life is editable, should we edit it? And if immortality is possible, will it be a blessing, or a curse? So what do you think? If gene editing could make you biologically young forever, would you take the leap? Or do you think death is a part of life that we should never try to erase? Drop your answer in the comments below. I'm curious to see what side you're on, and if you want to see how AI could be your personal guide to reaching 100, check out our other video. Because maybe the secret to living forever won't be a miracle, it'll be a choice. Thank you for watching. If you found this video helpful, share it and subscribe to join our journey toward a healthier, happier life. Goodbye, see you Aegean.